Let us continue the slides now. So look at the next one. So finding irrational numbers between two rational numbers. So in the last slide we have seen how to find out rational number between two rational number. But now we are going to see how to find irrational numbers between two rational numbers. Okay, for example, two rational numbers. I am going to take 4 by 5 is one of the rational number, and 7 by 2 for example. Okay, so 4 by 5 and 7 by 2. So these are the two rational numbers. How can we find out irrational number between these two rational numbers? Okay, so how can you find? So first we have to write in the decimal form. Okay, we have to write the rational numbers into the form of decimal. So 0 point. So if you add 0 here means 8 5s are 40. So 0.8. And what about here? So here 3 2s are 6, remainder 1, and 5 2s are 10. So 3.5. So now I'm going to find out irrational numbers or minimum 3 irrational numbers between 0.8 and 3.5. Okay. So what about the decimal expansion of irrational number? So decimal expansion of irrational number is nothing but non-terminating and non-recurring. Okay, so non-terminating, non-recurring. So according to that, we can find out, or we can write the numbers. So which one minimum number? 0.8. Which one maximum number? 3.5. So between this, we can write any other number. Okay. So for example, I am going to write 1.230, 2300, 23000, etc. Is it lies between these two or not? Definitely. And is it non-terminating or not? Yes, non-terminating. It's keep going on. And it is non-recurring or not? Yes, different set of numbers. Okay, 230, 2300, 23000. So different set of numbers are there. So it satisfies non-terminating, non-recurring. Or we can write 2.570, 5700, 57000, etc. So this number also lies between these two numbers. So likewise, you can write infinite number of terms. Okay, so what is the procedure means? So if you want to find out irrational number between two rational number means, first to find out that first write the given rational numbers in the form of decimal, and then write the decimal number which is satisfying this condition, that is non-terminating, non-recurring between the given numbers. That's it. That is the procedure. So how many numbers are available between two rational numbers? So infinite number of irrational numbers are there. In the similar way, how many rational numbers are available between two rational numbers means infinite number of rational numbers are there. Okay. Right. Look at the next one. Operations on irrational numbers. So operations on irrational numbers mean we have to addition, subtraction, this operations only. You already know that how to add two rational numbers. Okay. So for example, you can take integer also. So 2 by 5, 2 plus 5 means 7, already know that. And similarly 1 by 3 plus 1 by 2. How can you add this? By taking LCM, or you can make a cross multiplication. Okay. So divided by 6 equal to 5 by 6. So that is the addition of two rational numbers. Okay. But here irrational numbers are there. How can you use operations under irrational numbers? In a similar way, let us add 2 plus root of 3. Okay. So 2 is rational and root 3 is irrational. If you add rational plus irrational, the result will be irrational only. Okay. And if you subtract any number from rational to irrational, the result will be irrational. And if you multiply any other number with rational and irrational, the result is irrational. And if you divide any number by irrational, it will become irrational number. Okay. So if you operate any irrational number with any other rational or irrational, the result will be irrational only. Okay. And now I'm going to do some examples, sums. For example, what about root of 3 plus 2 into root of 3? So here 1 time root of 3 plus 2 times root of 3. So both are like terms. Like terms means we should add. Okay. So in front of root 3, here 1 is there, here 2 is there. So 3. And write root 3 as it is. So 3 root 3 is the answer. Okay. What about this one? Root 3 plus root 2. So these two numbers are different irrational numbers. So it is not possible to add. So you should write as it is only. It is not possible to simplify. Okay. And what about this one? That is 5 root 3 plus root 2 minus 3 root 3. Okay. Suppose 3 terms are there. So here root 3, root 2 and root 3 is there. Okay. So however, whatever it is, okay, how many terms are given and what type of terms are given, don't worry. First combine them according to the like term. Okay. So here can combine these are the two like terms because here also root 3, here also root 3. So 5 root of 3 minus 3 root of 3 and add, just write the different number in the last. Okay. This root of 2, sorry, root of 2. So equal to, so 5 root 3 minus 3 root 3. So we have to subtract the coefficients here. So 5 minus 3, 2 and write the root 3 as it is plus root of 2. So now both are different type of numbers. So it is not possible to simplify. So that will be the answer. Okay. And similarly, so look at here, root 2 plus 3 root 5 minus 4 root 2 plus root of 7 plus root of 5 minus 2 root 7. Now we are going to simplify this. How can I simplify? So here, how many different type of rational numbers, irrational numbers are there? So root 2, root 5, root 7. So 3 different irrational numbers are there. So we have to merge them. That means we are now I am going to write according to the like terms. Okay, combine the like terms now. So root 2 and other root 2 is here. That is minus 4 root 2. Okay, I combined these root 2 terms. Next to root 5 term is there. So here root 5 term is there and here also. So plus 3 root of 5 plus root of 5. And that remaining is nothing but root of 7 terms. That is root of 7 minus 2 root of 7. Okay. So in the given expression which contains so different kind of root numbers means you can combine like this. Okay. According to like terms. Now subtract it here. 1 time is there. Here minus 4. If you subtract it, minus 3 times root 2. Right? Plus, so here 3, here 1. So 3 plus 1, 4. So 4 times root 5. And what about here? Here 1, here minus 2. So minus 1 time root of 7. Is it possible to simplify again? No. All the 3 terms having different kind of irrational numbers. It is not possible to simplify. So leave as it is. Okay. And this is the addition subtraction only. And how can you multiply? Okay. So if you want to multiply this term with root of 2, how can you multiply? So with normal multiplication only. Okay. So with that is multiplication symbol is there over the bracket. Therefore you have to multiply this with the inside the bracket. Okay. As usually. So when you multiply these two means root of 2 into root of 2 plus 3 root of 5 into root of 2. Okay. Now multiply now. So root 2 both are same irrational number only. So we can multiply root of 4 plus 3 here root 5 and root 2. So multiply this. Root of 5 2s are 10. So root of 10. Okay, not root of 15 or whatever it is. When you multiply two irrational numbers and rational numbers, multiply rational number with rational number, irrational number with irrational number. Okay, that is the procedure. So it is not possible to simplify again, leave it because two different irrational numbers are there. And what about here now? Root of 2 into root of 4. So if you multiply means root of 8 only will come. Okay, similarly 2 into root of 5. Okay, so here it is rational number, but it is irrational number. So they are different type of numbers. One is rational, another irrational. It is not possible to multiply. Okay, so the answer is 2 into root of 5 only, but not root of 10. Okay, so some of you in the last time test you made this mistake only. Okay, so it is not possible to multiply a rational number with irrational number. Okay, so you can multiply with the same category. Either they should be rational number or irrational number. Okay, so this is the procedure to multiply two irrational numbers. Okay, one rational and irrational numbers. And what about for another one? For example, 2 plus root 3 into 3 plus root 2. Now we are going to multiply these two. How many terms are there? So here 1, 2, here 1, 2. So when we multiply, totally 4 terms will come. Okay, product only number of terms. Okay, for example, here 3 terms, here 3 terms, that means 9 terms will come. Right? So now choose 2 and multiply with these two numbers. Okay, when you multiply, 2 3s are 6. We can multiply because both are rational numbers only. Plus what about next one? Here 2 is there, here root 2 is there. So both are two different type of numbers. So write as it is. Don't multiply inside it. Okay. So 2 now over. Next take root 3 and multiply these two numbers. So plus, so here numbers are same but different type of numbers. It is not possible to multiply. So write 3 root 3 as it is. And again multiply the same with this one. So look at this. Here also root is there. Here also root is there. Both are same type of numbers only. So we can multiply. So root of 3 2s are 6. Okay. Is it possible to simplify here? Not possible. Okay. So leave it. Or you can do one thing. So 6 plus 2 root of 2 plus 3 root of 3. Can you split this root of 6 by root 3 into root of 2? So whatever it is not possible to simplify. You can keep as it is. Okay. So that is a procedure to product of two irrational numbers. Okay. Right. And then look at the next one, exponents. It is another chapter. That is another section. So exponents formula is there. Okay. So for example, how can we simplify this one? That is 81 power 1 by 2. So 81 power 1 by 2 is nothing but it is root of 81. That is a name. So root of 81 means the answer is 9, square root number. Or we can write this one in the another way. So the factors of 81 is nothing but 9 square and whole power 1 by 2. So more than 1 power means we should multiply the power. So this 2 get cancelled, equal to 9 to the power 1 equal to 9. So both are same answer only. Both are different types. Here you found root. Here you wrote, you used here the exponential formula. That's it. And one more thing here. Suppose cube root of 27. So it is called as cube root. Okay, not 3 into root of 7. So this can be written as 27 whole to the power 1 by 3. So only root is there, we can write 1 by 2. But cube root means we can write 1 by 3 only. Okay. So how can you factorize 27? According to the denominator. So denominator of the power is 3. So that we can factorize 27 with the power of 3. So 3 power 3 whole to the power 1 by 3. So when you multiply the power, the 3 get cancelled, the answer is 3. What about fourth root of 16? So 16 power 1 by 4. So we can write this as, so 16 how can I write with the power of 4? Because the denominator is 4 here. So that's why. So 2 power 4. So power 1 by 4. So this 4 get cancelled, equal to 2. So what about the root they are asking here? We can split the base number according to the denominator of the power. Okay. So look at this one. That is fifth root of 32. How can you write? So 32 power 1 by 5 equal to, so we can write this 32 into the power of 5. So 2 to the power 5 and whole power 1 by 5. So this 5 get cancelled. So answer is 2. Okay. So this kind of roots, everything they are asking means we can do like this only, right? And already you know that the base are same means we should add the power, right? And the base having more than 2 power means we can multiply the powers. And the base are different and powers are same means we should multiply the base and apply the same power. The same formula. Okay, go through the formula also, right? So the maximum sums also it will come from exponents. Okay. So just revise the chapters, okay, with the help of this revision, and still if you have any doubt in lesson number 1 means ask me, I will clear doubt. Okay, thank you.